Well, hello to Honors Algebra 2, to Mr. Patterson's class and Mr. Clendenin's class. This is Mr. Clendenin, so you're going to hear my voice again today. Now, today we're going to do a video over the graph of the tangent function, and you did an activity yesterday on it. That was like your activity from Monday. So have that activity handy along with your notes for today, and we'll go through this slideshow, this video here, and we'll reference both of them. Okay. Now, the first thing you did on yesterday's activity was you checked with the tangent graph, you checked our 5 points that we used for the sine and cosine graph. 90 is pi over 2, 180 is pi, 273 pi over 2, and so on. And you found out you got answers over here that really didn't give us much help for getting our graph drawn. Whenever we did sine and cosine of those 5 points, we always got answers of 1, -1, 0, and it helped us lay out our 5 points to get our graph drawn. With the tangent, we got these two undefined values in here, and everything else gave us, we got a bunch of zeros, so it didn't really give us any help to drawing our graph. Okay, so in your activity, you had to plug in some angles here. Then notice that all these angles are negative angles, which means they're all in the fourth quadrant. And look at your answers you got. Yes, you got an undefined, and you got a 0 and a -1, but you also got some other answers here. Notice that you got two answers, -3.73 and -1.73, that you wouldn't have got on sine and cosine, because the sine and cosine graph, remember, have a range. They're bounded on their range from -1 to +1. All the answers you would have gotten on sine and cosine were between +1 and -1. Okay, here we're getting answers that are bigger than, or in this case, smaller than -1. And then in your first quadrant here, these positive angles, we got the same, again, just like from Monday activity. You got the same answer. You got 0.27 here. Over here you got -0.27, and so on. And you got two answers again, 173 and 373, that are bigger than 1, and we did get an undefined. So we're getting some answers here that can help us. But how do we handle an answer of undefined? We take the tangent of 90 here. Our calculator says error. What do we do? What do we do with undefined values? Well, you should remember from chapter 9 on the graph, when we have undefined values in our domain, we have to exclude them. How do we exclude them? With asymptotes. Okay? Now, if you're in my class, you're going to remember something about asymptotes, and I got a reminder yesterday. I got an email with a picture attached to it, and here it is. Remember this guy? Audrey? Who is that? That's Walter. Remember what Walter does with asymptotes? He runs right along them like a dog fence. Kaylee, Audrey, what is that? What hour is that? That's second hour. They remember this. My class will remember this. Mr. Patterson's class won't remember this little nugget of information here, but we have Walter the dog coming back to visit us here. Okay, again, Mr. Patterson's class, you won't know what we're talking about. My classes will. But if we graph those points that we got in that second table, here they all lay out. Okay, or here's how they lay out. And we see here that our graph is taking off to the moon here. And what's it doing? It's running right along that asymptote. So there's Walter running along the dog fence, getting closer and closer and closer, but never touching it. Same thing down here, just like before. We're running along the asymptote. But it keeps shooting up as high as it can and down as low as it can. So there's no ceiling on the tangent graph, and there's no floor. I don't know if I spelled ceiling right there or not. Maybe. That's why I teach math. And there's no floor. Okay? Yesterday in your cosine and sine curve, your sine curve and your cosine curve, they had a ceiling at +1. They had a floor at -1. We don't have that today. Okay? There's no bounds on our range today. Okay? Now, couple things to notice about this graph that will happen in every tangent graph. Number one, it's heading as high and as low as it can possibly go. But we have these two asymptotes, and they're spaced apart, in this case, 180 degrees. Now, what happens to us if we go another 180 degrees down the line here, which would be at 270? What do you think is going to happen? Well, it's going to be another asymptote. And if we went another 180 degrees down the line, there would be another asymptote. Same thing if we go in the negative direction. We go 180 degrees in the negative direction to negative 270, there'll be an asymptote. Every 180 degrees in both directions, there'll be an asymptote. And then what happens in between those asymptotes? You have the exact same graph repeat itself. Like that. Okay, so this graph continues on to the right and left, just like the sine and cosine graphs do, including, in this case, including the asymptotes. Good thing about it is we know exactly where our asymptotes are, how far apart they are, if we know this distance in here, okay, which is called the period. We're going to get to that. Okay, so we have this periodic, meaning repeats itself on down the line. It's not just one, it's not just that picture, okay, it's being repeated to the right and to the left. I want to make sure you keep that in mind. All right, now domain and range. We talked about domain and range with sine and cosine real quickly. For sine and cosine, remember your domain, what angles can you take the sine and cosine of? There's no exceptions to it. You can take the sine and cosine of any angle you want. What kind of answers do you get? What kind of range values, y values do you get whenever you do a sine and a cosine? Well, there is a limitation to that. All of those have to be somewhere between -1 and +1. It's different for the tangent, okay? So here, first off, let's do the range first. So the range are our y values. Well, remember your graph extends north and south here without any bounds, so that means we don't have a limit on our range. Our range can be whatever it wants to be. Doesn't have to be trapped between -1 and +1 like the sine and cosine curve do. Now our domain, what angles can we take the tangent of? Well, we saw whenever we punch in our calculator, sometimes we get undefined values. We got them at pi/2 and -pi/2. So we cannot, like the sine and cosine curve, we can take a sine and cosine of any angle you ask us to, but not for the tangent. We have these asymptotes, these undefined values we have to worry about. So the way we say this is we say the domain of our tangent is any real number except where our asymptotes are. Okay? Now remember, these asymptotes repeat a zillion times in both directions. So how are we going to say where our asymptotes are? Here's what you do. You take this right-hand asymptote right here and you say all reals except that right-hand asymptote, pi/2. Then you say, well, where's the next asymptote going to be? Well, it's going to be 180 degrees down the line. Now we don't use 180, we use pi. So we added pi to get the next asymptote, and we could keep adding pi to get to another asymptote. And then to go the other direction, what will we do here to get to that asymptote? We would subtract pi. How we go from this asymptote to that asymptote? You would subtract pi. So we say we either add or subtract pi from that right-hand asymptote, that pi/2, and we can do that k amount of times. Okay, that's the way you say your domain for a tangent graph. You know, it's this right-hand asymptote plus or minus the period, the distance between them here, k times. Okay, we'll do some more of that. Maybe it'll become clearer. Okay, from Monday and Tuesday, we talked about the period of a graph and the domain and range. Now for the sine and cosine, remember that your period was 2 pi. Okay, for tangent, the period is pi. And what you want to realize about this period, it's simply the distance between your asymptotes. Okay, that's how you want to remember, or how you'll use the period of the tangent graph. That's the distance between your asymptotes. Again, your domain for sine and cosine, there was no exceptions for the angles that we could take the sine and cosine of. For the tangent graph, or the basic tangent graph, we can take the tangent of any angles we want except that pi/2 plus or minus pi times k. And our range for the tangent we can get any answer imaginable. We can have answers of 103. We can have answers of negative 75. For sine and cosine, we had to get answers between negative 1 and positive 1. Okay. Now, an easy way to think about how we write this. All right. Again, what's the format of how we write this domain? Well, it's that asymptote plus or minus, what's this pi? That's the period of a tangent graph times k. So kind of remember that format. That'll come in handy later. It's an asymptote, the right-hand asymptote, plus or minus the period times k. Then with our sine and cosines, when we started to graph them, the a value and the b value that we see in our function become important. And you remember, for sine and cosine, the a value is called the amplitude. But we got a little issue here calling it an amplitude for a tangent graph, because remember, with this, for instance, a sine curve, the amplitude means the height and depth of the wave. We don't have a height for a tangent graph, so we can't call this an amplitude. But we will use the a value to generate our tangent graphs, and you'll see how in a second here. But if it is negative, the tangent graph is inverted just like the sine and cosine. Now, how this will work, you either have a positive tangent graph, which is the one we just had earlier, looks like that, if you can see that, or we have a negative tangent graph. Now, what would a negative tangent graph look like? Well, this would be this one here inverted. Well, what would that look like? It would look like that. So think about slope, okay? This was a positive tangent. What did it do? It went uphill. This is a negative tangent. What did it do? It went downhill. So remember slope when we're drawing our tangent graphs. All right, time to graph our first graph here. Y equals 3 times the tangent of x. Okay, we're still going to eyeball this and say, hey, we got an a of 3 and a b of 1, just like you did with sine and cosine. Now with sine and cosine, you would have said your amplitude is 3. Again, we don't have an amplitude in the tangent, but we do want to recognize that 3. We're going to use that 3. Now, how do we use it? Well, when we draw our graph, that's going to be a positive 3. Don't need a dot there. And negative 3 are going to be important to us. Okay, so those will go on the y-axis. And for tangent, or for sine and cosine, the next thing we did was the period, which was for sine and cosine, was 2 pi over b, okay? That's for sine and cosine. For tangent, it's pi over b, so ours would be pi over 1, which is pi. Now, how do we use this in a tangent graph? This is how far apart your asymptotes have to be, okay? It has to be pi apart. Now, what I'm going to do with it, I'm going to divide it by 2. And I'm going to say, okay, that means pi over 2. Well, why did I divide it by pi over 2? Well, from the origin in here, I'm going to go pi over 2 to the right and pi over 2 to the left to negative pi over 2. And then what's the distance between those two? Pi. Okay? Let me clear some of that out of there. Now, what's going to happen, just about erased everything there. What's going to happen at pi over 2 and negative pi over 2? That's where your asymptotes are going to be. All right? Now, if you remember in your chart, you can look back to your activity, when we did the tangent of 0 in here, that's when we got an answer of 0. So we have the origin 0, 0 is part of our graph. Now, how does this 3 come into play? Well, at this midpoint in here, what's in the middle of 0 and pi over 2? Well, it's pi over 4. What's in the middle of 0 and negative pi over 2? Negative pi over 4. What's special about those? What's going to happen at those points? That's where you will be at 3 and negative 3. And it was a positive 3, so we know that we are running uphill, positive tangent graph. And there you go. That's how we graph a tangent graph. Now, I will point out one thing. If we just graph the basic tangent graph, y equals tangent of x, so in other words, a is 1 and b is 1, then our asymptotes are at pi over 2 and negative pi over 2, just like ours were here. That was because the b was equal to 1. But this a value is 1, then the points in here are 1 and -1. Like that, okay? So what's this height right there? It's 1. What's our height over here? 3. How did that happen? That's how that a value kicks into play. So you can say, what did this a value do? It made it 3 times taller, if you want to think about it that way. That point right there became 3 times taller. Okay, and this one over here went down 3 times further. Now remember, you can pause this video, rewind, all that good stuff to help you if I'm going too fast for you. I apologize if I am, trying not to here. All right, y equals tangent of 2x. So here we have an a of 1, which is the normal. But our b value here is 2, okay, which means what will happen to our period? It will be pi over 2. Now again, that's the total distance between our asymptotes. So if I divide that in half, I get pi over 4. So when I draw my graph, where are my asymptotes going to be at? Well, pi over 4 on the right hand side, positive pi over 4, negative pi over 4 on the left hand side, negative pi over 4. There's my two asymptotes. My a value is 1, so my y-axis will be labeled positive 1, negative 1, and 0. Then what is this midpoint in here? Well, what's in the middle of 0 and 1/4? 1/8 pi over 8. Over here, negative pi over 8. Now, why are those 2 points different or important? That's where your graph will be equal to positive 1 at here on the right hand side, and where it will be equal to negative 1 at on the left hand side. It is a positive tangent, which means it goes uphill. So now I can use my asymptotes and those 3 dots to get myself drawn, and there we go. There's Walter running along the asymptote. Okay, you can try number 3 on your own, then pause it. When you come back, I'm going to have it completed and we'll talk about it. Okay, what do we have here? Well, we have an a value of 3. Okay, so we can lay out our y-axis. We have a b value of 1/8, so we divide by 1/8, it gives me 8 pi. That's going to be the total distance between my asymptotes. Okay, and if I divide 8 pi by 2, I get 4 pi, so that means this right-hand asymptote is at 4 pi, or it's plus 4 pi from 0. Left-hand asymptote is at negative 4 pi, so it's minus 4 pi from 0. Then the total distance between them is 8 pi. In the middle in here would be 2 pi. In the middle over here would be negative 2 pi. It is a positive 3, so this graph needs to run uphill like this. So that means when we're at 2 pi, we will be at positive 3. When we're at negative 2 pi, we'll be at negative 3. And we will look something like this. Okay. Now I want to point out a couple things that I haven't done yet. If this equation would have been, everything's the same except it's negative 3 times the tangent of 1/8 x. So it's a negative tangent. What changes? Not a whole lot changes except for the direction of this graph. If it's negative, it's got to run downhill, so it would just run like that. That's how you handle a negative a value. The other thing I want to point out is this 1/8. It's right in there, that 1/8. This distance, this total distance here, let me clear off some stuff. That total distance in there is 8 pi between our asymptotes. Okay, on the basic sine, or basic tangent graph, the distance between our asymptotes was pi. Well, what's happened here? We've multiplied by 8. That's what a 1/8 does to you. Now, in the previous problem, the b value was 2. So if you noticed on it, our original asymptotes would be at pi over 2 and negative pi over 2, and the distance between them is pi. On the last problem, where were they? It was pi over 4 and negative pi over 4. So what happened? It's half as wide. That's what that positive 2 in there for that b value did to us. Okay. Now let's look at one more real quickly on how to generate the graph of a tangent. So here we have how to generate the equation of a tangent given a graph. So we know in our tangent equation it's y equals a times the tangent of x. Where does this a value come from? Well, it's right in here at this midpoint. Where is it? Well, this one's at 2. So that means our a value is 2. Okay, that's how we get our a value to be 2. Excuse me, I forgot my b up here. So it's a times the tangent of bx. Well, where does the b come? Well, the b will come from these asymptotes. How far apart are they? Well, let's check. This one says pi, if you can read it, and this one says negative pi. So that is a distance of 2 pi. That's the new period for this graph. So remember how this works. The new period equals the original divided by b. Well, we know our new period is 2 pi. What's the original period for a tangent? Pi. So 2 pi equals pi over b. Put that over top of 1, cross multiply, you get b to be 1/2. So our equation was, for this graph, was y equals 2 times the tangent of 1/2 x. Hope I did a decent job explaining this. This is a rather long one. Sorry about that, but you can pause it and rewind it and watch them again if you need more explanation. Let Mr. Patterson or myself know. Hope everybody's doing okay. We'll see you.